In this recording, we're going to look at the inverse trig functions, specifically inverse sine, inverse cosine, and inverse tangent, and the graphs. Before we do that, I'd like to back up and look at some stuff we knew about functions earlier in the year. So you can do this on your cumulative review, or you can do this right on the notebook paper that you just wrote your heading on. I'd like you to write down each one of those prompts, leave a little space below, and then sketch a graph to represent each one of those. Play the recording when you've made your own graphs. Okay, at this point, hopefully you've made each one of those graphs, and I'll reveal my answers. Knowing that my answers could differ from yours, you have to have certain characteristics. Okay? So, first one, a function that is not a relation that is not a function has to fail the vertical line test. Function that is not one-to-one, fail the vertical line test, pass the vertical line test, and fail the horizontal line test. A one-to-one function has to pass both the vertical and horizontal line tests. A one-to-one function that is onto has to pass the vertical and horizontal line test to be one-to-one. To be onto, its range has to extend to all real numbers in the y direction. A one-to-one function that is not onto. So it's one-to-one because it passes the vertical and horizontal line tests. It's not onto because its range is restricted. It's not all real numbers. And finally, a function that is neither one-to-one nor onto. So it's a function because it passes the vertical line test. It's not one-to-one because it fails the horizontal line test. It's not onto because its range is not all real numbers. Now with that background, I'd like to start looking at the inverse sine function. We're going to come back if you're wondering, well, why do we talk about one-to-one and things like that? Turns out a function, in order for its inverse to also be a function, that function must be one-to-one. So, let's consider the graph of sine of x. So, you don't need to write this on your notebook paper. I would like you to write the heading, the inverse trig functions. Okay, you're very familiar with this graph of sine of x, and our challenge here is to give a restriction on the domain. Obviously the domain of this is all real numbers, but it's not one-to-one, right? Fails the horizontal line test many times. So I want to make it one-to-one, and I also want to include 0 to pi over 2. So this portion of the graph right here from 0 to pi over 2 I'm going to include. If I were to extend past pi over 2, so I'm going to include this portion right here. Okay, if I were to extend past pi over 2, it stops being a one-to-one function anymore, right? So I'm going to extend this way, but when I extend this way, I can't go beyond negative pi over 2, or again, it's not a one-to-one function. So I should have something like this, including the endpoints. And so the restriction would be from negative pi over 2 to pi over 2. Great. Let's consider the cosine graph. Okay, there's your cosine graph. Again, a restriction on the domain. I have to include 0 to pi over 2. But I'm not going to extend in this direction as I did with sine, because that wouldn't be a one-to-one function. Instead, I'm going to extend further until I get to pi and stop right there. That makes a one-to-one function. Any continuing in either direction would prevent it from being one-to-one. Okay, so that restriction is 0 to pi. What I've got in red is from 0 to pi radians. Finally, our tangent graph. I just barely learned about this graph. Looks like this, has vertical asymptotes. Okay, goes through the origin. I want to include this portion of it between 0, okay, and pi over 2. That's our first quadrant. I guess I could go over here and still not violate the one-to-one, but then I would have a discontinuity in the graph. I'd rather go in this direction, so I think that's what I'll do. I'll go between negative pi over 2 to pi over 2, but not include the endpoints like I did with sine, because there's asymptotes there. It never really reaches pi over 2, negative pi over 2, so we have parentheses. Okay. Let's see what that might look like on our graphing calculator. So if you have a graphing calculator, I'd like you to take it out and play the recording when you're ready. So I'd like you to put into your y equals sine x, and then we'll go up and we'll do zoom 7. There's a graph of sine x just like before. If I wanted the inverse of that, remember switch x and y? Another way to say it is reflect over the line y equals x. So let's go over to y equals, and in y2, let's put in x. Let's graph that. Here comes a red line, the graph of y equals x. So there's a feature on your calculator that will reflect over the line y equals x any graph. You're going to hit second, then you're going to hit the draw menu. That 8th choice down there, draw inverse. Alpha, and the trace button to get to y1. When you're ready, hit enter, and you're going to see a blue graph here that's sort of snaking along the y-axis, reflecting the sine graph over the line y equals x. Let's see a little bit more of this. Let's zoom out by hitting Window, and let's scroll down, and let's go from -8 to 8 in the y direction. Let's hit graph. Here comes our sine graph again. And then we're going to see the line y equals x. And now we're going to come back here, quit out of here, just hit enter, and it will repeat what you just did. Same function. So you can see this is serpentining along here like a vine. Clearly not a function, right? It's not a function. But the portion of it that is a function is right here in the middle. Right here in the middle. This portion is a function, and then it stops being a function. So between, I don't know, 1.5 and -1.5. If you remember, 1.5 to -1.5 is pretty much negative pi to pi. Okay? Okay. So let's go back to our y equals. Let's clear out those two functions. And let's just have it graph the inverse sine. So we'll hit second, sine of x, close a parenthesis. We're going to hit zoom 7. And there's that little portion. Remember, it would serpentine, it would snake its way down and up the y-axis, but it wouldn't be a function unless I restrict it between negative pi over 2 and pi over 2. Notice it doesn't quite get all the way to where it should. The calculator sort of fizzles out here. It doesn't like to draw pixels that are vertical. What I need you to know about this inverse trig function is pretty basic. So you can always, if you need to identify the graph in a multiple choice question, you can always grab your calculator and compare this graph with that of the inverse cosine. Okay? Let's go back and, oh, I guess this is another thing. If you didn't see any graph, if it didn't show up, I'm guessing it's because your mode is in degrees. It has to be in radians. So if you didn't get a graph, change your mode to radian, then hit zoom 7. The inverse sine, I'd like to have you write this down in your notebook. This is the inverse sine notation, as you're familiar with. It's for finding unknown angles. Equivalent to that is the arc sine. Okay? If I could have you make a small change to what's printed here, I'd like you to write this S as a capital and this A as a capital as well. Okay? Has a domain of -1 to 1 and a range negative pi over 2 to pi over 2. You can kind of see that here. It gets down to about almost -1.5 up to +1.5. Take 2. Okay, so this is what I'd like you to write in your notebook. Our conclusions. So inverse sine. We know that this notation, sine with a -1 superscript, is read the inverse sine of x. It's for an unknown angle. Okay. What I'd like you to do though is write it with a capital S unlike what's written here, because that means it's a function as opposed to that one that failed the vertical line test that we saw in the calculator. An equivalent expression, just like in math there's different ways to say the same thing, is arcsine of x. Again, I'd like you to write it with a capital A, kind of like I've got down here. An arcsine of x, like I wrote at the bottom, just means the angle who has a sine that is x. The angle whose sine is x. Okay? I'd like you to make this graph. As you can see, this is the same graph we just saw on our graphing calculator. It goes between negative pi over 2 about down here at negative 1.5 up to pi over 2. That's its range. I'd like you to make that graph, write this information, play with the recording when you're done. Okay, now let's look at the inverse cosine graph. Okay, this one looks just like on our calculator. It goes between pi and 0, in other words 0 to pi. I'd like you to write this with a capital C. Inverse cosine. Arc cosine, just down like down here, means the angle whose cosine is x. And again, we can see its range is between 0 and pi. Okay, so jot down those conclusions, make that sketch, play the recording when you're done. And finally, our inverse tangent graph. Again, you're going to write it with a capital T, okay, and a capital A here. We saw this same graph on our graphing calculator. Looks like it has a horizontal asymptote right about 1.5, which would be about pi over 2, and down here the same thing. It's because its range is restricted. Its range is between negative pi over 2 and pi over 2. Parentheses here. I'd like you to write down that information, sketch that graph out, and then play the recording when you're ready. Okay, finally, I'd like to try to make a little bit of sense out of this arc. Try to make this intuitive. Okay, so I'd like you to write down the information that's on this screen, both the inverse sine notation and the arc sine notation, and the 3 unit circles. I'd like to play the recording when you're ready. Okay, so what we're going to try to do is determine what out of this whole arc we should include. We're going to include the first quadrant. Obviously, that's where everything's positive. If I were to include the second quadrant, sine's positive there too. So I'm going to include the first quadrant and the fourth quadrant. So if you have some color, I'd like you to sketch first quadrant and fourth quadrant, that whole arc. Remember, it's an arc for which sine is defined. So there's only one value of each number for sine, each y value between negative 1 and positive 1 within that arc. And of course, isn't that between negative pi over 2 to pi over 2? That's what we saw the restricted range was before. Similarly with cosine, we're going to include the first quadrant. If I were to use the same arc as with sine, they'd be all positive. Remember, all, and then this is the cosine quadrant. So I need to include the first quadrant and the second quadrant. Okay? So I've got the first and the second quadrant included. That includes all x values. Remember, cosine is the set of x values, so I include all possible x values between negative 1 and 1. Well, isn't that the angle 0 to pi, the arc? Finally, tangent. We're going to include the first quadrant, just like we always do, because that's where everything's positive. I could go into the second quadrant, because tangent's negative there too, but remember it's an undefined. I'd have an open dot up here at the top. So instead, I'm going to go first quadrant and then into the fourth quadrant. However, I'm going to have open circles on the end. Okay, because tangent's undefined, negative pi over 2 and pi over 2. I have open circles there, which lead us to this interval for the range of inverse tangent, negative pi over 2 to pi over 2, which is often confused with the sine, because this one has open circles, it has parentheses, meaning it's not including the endpoints. Okay? Thank you for watching.